Hey, Trenton. I can't believe I've never asked you this before, but what's your favorite dinosaur?
Well, I think my personal favorite would have to be the Triceratops. Love a good herbivore.
Oh my gosh, dude, that's my favorite dinosaur too. Who can go wrong with the little three-horned cutie?
Well, speaking of dinosaurs, have you heard the latest research about how animals adapted after the dinosaurs went extinct?
No, I haven't, but I'm actually a little confused about how the dinosaurs became extinct in the first place.
No problem, Oscar. I'm happy to explain all about it, but first, let's take a look.
A new study led by the University of Texas at Austin analyzed core samples from the Chicxulub crater in Mexico's Yucatan Peninsula. The team used it to assemble a timeline of what happened after the dinosaur-killing asteroid crashed into Earth. Researchers estimate that the asteroid struck a shallow ocean some 66 million years ago, hitting it with the force of 10 billion atomic bombs. The blast set the land ablaze, igniting trees and plants up to thousands of miles away. The impact then triggered a massive tsunami several hundred meters high and moving away from the crater. According to the New York Times, it also catapulted rock into the upper atmosphere. Lead author of the study, Sean Gullick, said the largest debris pieces fell back down to Earth in minutes. Smaller particles lingered longer and fell across North America as tektites, glassy orbs that form when molten rock cools while falling. Charcoal fragments and chemical biomarkers of soil fungi found above sand layers inside the sample indicate that charred remains on land were pulled back into the crater by the receding tsunami waters. Perhaps the most important discovery made during the study is the absence of sulfur in the core, even though the area around the impact crater is full of sulfur-rich rocks. This supports the theory that the asteroid impact vaporized sulfur-bearing rocks at the site, releasing the mineral into the atmosphere, where it reflected sunlight away from the planet and caused global cooling. According to researchers, 325 million metric tons of sulfur is estimated to have been released by the impact. Although the asteroid caused destruction at the regional level when it hit, the impact itself was not what killed off the dinosaurs. Instead, researchers say the global climate change that followed was responsible for the mass extinction of the dinosaurs. Global cooling disrupted photosynthesis, which killed the plants and caused the food chain to collapse. The nightmarish sequence of events detailed in the study are what scientists have long hypothesized to have happened. Only this time there's evidence to back it up, and set in stone, no less. The New York Times reports that early this year, another study found fossils of fish, trees, terrestrial vertebrates, and marine creatures near an ancient lake in North Dakota. Shockwaves from the asteroid are believed to have flung them on shore, where they died buried in mud.
So, Trenton, if the asteroid had never hit Earth, would the dinosaurs still be around? I would have been able to see a Triceratops? Dang it!
Well, I mean, maybe they would still be here, but if dinosaurs hadn't been wiped out by that asteroid, humans probably wouldn't be here either. So you're definitely not missing out on seeing those Triceratops.
That's a good point, Trenton. I guess I just had to accept that I'll never get to see Triceratops.
I find it interesting, though, that the asteroid wasn't the ultimate cause of the dinosaur extinction. Instead, the effects that the asteroid left behind on Earth were the main contributor. As the video explained, when the asteroid hit our planet, the blow set the land on fire, harming plants, trees, and wildlife. The asteroid also caused lots of sulfur to be released into the atmosphere, which then caused global cooling. Because dinosaurs were reptiles, which were cold-blooded animals, they did not respond well to the cool weather and lack of sunlight. Additionally, as the Earth got cooler, less food was available and it created a huge disruption in the food chain. These factors ultimately led to the extinction of the dinosaurs.
Now I understand how the dinosaurs went extinct, but can we go back to your initial question, Trenton? Something about how animal adaptation was affected by dinosaur extinction?
Yes, that's exactly it. I'm happy to explain. Animal adaptations are when an organism adapts or becomes better suited to survive in its habitat. A great example of this would be how polar bears slowly adapted from being brown to eventually having a white coat in order to camouflage in their Arctic environment. This newfound research explains that mammals adapted to get bigger in size after the dinosaurs died. Mammals are warm-blooded organisms, they have live birth, and they have hair. Mammals were able to grow in size because they adapted to the cooler climate, now had access to more food, and access to different environments. Previously, mammals were much smaller, but with large dinosaur predators gone, they adapted to become bigger. Researchers who analyzed the fossils of mammals from the Paleocene epoch, which is the period of time immediately following the extinction of dinosaurs, found that while mammals' bodies got bigger, their brain size in relation to body mass actually got smaller.
Wait, so the mammals got bigger, but their brains didn't? Aren't mammals supposed to be super smart, though?
Well, yes, but at first, no. Their body size evolved first, but the evolution of the mammal brain took a bit longer. Let me explain further. Other researchers performed CT scans on fossils from two different epochs, the Paleocene epoch, which was 56 to 66 million years ago, and the Eocene epoch, which was 34 to 55 million years ago. They analyzed and compared the brain size of these fossils and found that brain growth didn't kick in until further in the Eocene epoch. They found that brain growth occurred because competition for food and resources intensified, and complex behavior became more vital for survival. Prior research suggests mammals' brains grew first, but it was actually their body. However, mammals' brains have caught up with their bodies, and today's mammals now have the largest brain to body size.
Wow, Trenton, that's pretty cool. It's kind of crazy that us mammals got bigger and eventually smarter due to the dinosaurs going extinct.
I know, Oscar, it's pretty crazy. I guess you could say the fall of the dinosaurs led to the rise of the mammals.
Definitely.